If I haven't met you, I'm Andrew Brahim, Principal Engineer at Ascend Engineering. So today I'm going to be talking about a technology stack I'm really passionate about, something I've worked in my spare time. So we're going to be combining PX4 Autopilot with ROS2 on a Jetson Orin. So you ask, why do I need a Jetson on my drone? Well, there's a few use cases. In general robotics, you can use a Jetson for like real-time mapping. So NVIDIA Isaac ROS, they have NV blocks. So basically, you're accelerating parts of the stack where you would probably be constrained on the CPU. Another use case, fiducial markers are another thing that you could definitely leverage a GPU for. But for this presentation, we're going to focus on VIO, which is Visual Inertial Odometry. That's going to be the main emphasis of this talk. So I'm going to take a little trip down memory lane. Anyone remember building their first PC?
Yes.
So do you remember your first graphics card?
Oh my God. Had the coolest box.
Yeah, I feel like back then, yeah, they had to get creative with the box design art. So mine was a GeForce 2. This is like the early 2000s. Very, very basic card. And so, you ask why are we talking about graphics cards? Well, that's how NVIDIA started. It was rendering back in the early 90s. That's how they were able to accelerate their business. And so what we found is that throughout the years, they hit a lot of breakthroughs. You have AI and machine learning. You have LLMs as of recent. But this talk's more focused on the embedded or edge devices like the Jetson Orin. In 2019, NVIDIA came out with the Jetson Nano, the original one. And fun fact, the same processor on that, the system on a chip, is a scaled-down version of the same processor on a Nintendo Switch. It's the Tegra X1. And so we kind of fast forward to recent times, and we have the release of Isaac ROS, which is basically NVIDIA's accelerated robotic stack that's wrapped. Basically, you're wrapping CUDA libraries in ROS2. And then you might ask, why PX4? Why not another autopilot? So I think PX4 has a few things going for it. So internally, PX4 uses a ROS2-like pub sub called uorb or microorb. So I think that lends well to being able to bridge to ROS2. And so we do that via uxrce DDS. It's kind of a mouthful. I just call it micro DDS for short. I've heard someone call it Xerxes. I don't know why. I don't call it Xerxes. In PX4, we have something called the DDS topics YAML. So basically, that's where you're able to pick and choose what uorb topics you want to bridge. And then on your companion computer, on your Jetson, you want PX4 messages. So basically, ROS2 has it doesn't know what a PX4 message or any of the uorb messages are. So you basically need to pull down the PX4 messages repo to decipher that. So I did a little experiment with trying to run Isaac ROS Visual Slam, which is a VIO stack. So basically, the hardware I use a Jetson PAB. Just to make things easy, you don't have to. You can use a standalone Jetson and a standalone Pixhawk. But I think the Jetson PAB with the integrated Ark FMU is just really easy to use. You'll also need something like a RealSense D455 or a D435. Not necessarily you can use like a traditional stereo pair. You just have to do a little bit more work, like publish the transforms manually. Whereas the RealSense API will kind of do most of the work for you. So I used a 450 millimeter wheelbase drone, not a relatively big drone. I can still fly it in my garage. But you can probably get away with a 650 size if you're flying in a big warehouse or something. Optional, but if you're not using a RealSense, you might need a checkerboard pattern to calibrate your stereo pair. So getting into kind of the technical Isaac ROS stack that you'll need to set up, it gets a little complicated. There's some nuances, there's some gotchas. The biggest one is with the latest Isaac ROS 3.2 for the Jetson Orin. you need at least Jetpack 6.2. Now on the Jetson Orange, it may ship with Jetpack 6, and that's not going to work because of the QV SLAM dependencies. So you'll need several packages, including Visual SLAM, which is the core ROS2 wrapper around QV SLAM. You'll need Isaac-ROS Nitros, which is a lot of packages. It brings in a lot of dependencies, so it's a very complex build. And this is all done in Docker NVIDIA Container Toolkit. The other thing you'll need, and I alluded to this earlier, was PX4 messages to make that translation layer. The Magic Enum repo is something that a build issue I ran into, and I realized that NVIDIA is not really testing the Isaac-ROS releases correctly. They're not really testing the builds, so I have to go in and kind of manually fix things in the build to get it to work. And then lastly, I think this is important, you probably want visualization, especially you want to be able to see like your gravity vector. You want to be able to see like the points, the features. So you could use RViz2, which is built into ROS2, or you can optionally use Foxglove. Software continued. So it is a long list. So NVIDIA Container Toolkit, basically, you want to run Isaac-ROS in Docker. There's just so many dependencies. You don't want to break your file system. Ark OS is optional. If you do get the Ark PAB, I think it's pretty easy to install, and I think you probably should. It comes with uxrce DDS agent, but you can just pull that down manually if you want. Now, Allen ROS2, basically, you're able to determine your IMU noise parameters, which is very important for QV SLAM. So without those IMU noise parameters, you're not really going to get a good gravity vector. You're not really going to get good localization. And then the last package I think is really helpful. It's from Ark. Jacob Dahl did a really good job with this Isaac VIO bridge. So if you ever see like someone doing like this, they're not trying to flick you off. It's the transforms, right? So ROS2 is FLU, whereas PX4 is NED. So you're able to make that translation through the VIO bridge. And then I have a little graphic that kind of goes over the uxrce DDS architecture. So people have done this before. It's not impossible to do. It's not impossible to get a drone to localize well with Isaac-ROS Visual SLAM. It just takes, there's a lot of steps involved. There's a lot of moving parts. So I found this project on Hackster by a gentleman named Andrew Burness. He doesn't use uxrce DDS, he uses MavROS. But the end effect is pretty much the same. He uses a RealSense D35, and then he's got a standalone Jetson. You can see the image. And then I have a little QR code to his Hackster project. So it's definitely not a beginner-friendly project, but it's doable. With enough time, I think it's possible. And then so I'm kind of going to get into my gripes with Isaac-ROS Visual SLAM and my experience with trying to get this to work. The first thing is, and I know this is an open source summit, QV SLAM is inherently closed source. So most of NVIDIA's libraries are closed source. So that's one of the big strikes against it. You don't really know what's going on under the hood, and so some people have an issue with that. The other issue is, so Isaac-ROS releases, they target hardware. They don't just target like software revisions. So 3.2 was the last release that supported the Jetson Orin Nano and NX. The 4.0 releases are all targeting the NVIDIA Jetson Thor, which is not as great of a platform to integrate on a smaller drone. Unfortunately, 3.2 doesn't support RGBD cameras. You can only use stereo pairs, and it also does not support mono-inertial either. The other issue I've run into is maybe issues with the gravity vector. Maybe your transforms are not correct. And then I talked about this earlier, building issues. It's over 70 packages in ROS2 just to get this to work. So it's quite a bit of dependencies just because of that Nitros image transport layer. Some other issues that you might run into, camera calibration. With the IMU noise parameters, when you run Allen ROS2, like people say, let it run for a few hours. Other people say, oh, let it run overnight. I'm not sure. But if you get consistent IMU parameters, then you're probably doing something right. The other thing is, from the PX4 side, you may not need to play around with the EKF parameters too much for VIO. But you might have to play with like noise or something. It all depends on your setup, right? And then one of the issues that, and this issue I have run into is when you're running visualization and trying to fly the drone, sometimes probably just due to the limitations of the ROS2 transport, you'll run into localization issues. So you might have a drop in VIO, or you might have inconsistent VIO publishing. So with all these issues in mind, I thought, well, let's at least explore some alternatives. And so what I've found is that the alternatives are not as user-friendly as setting up Isaac ROS. So I did take a look at OrbSlam 3, which is promising. However, you need some kind of IMU fusion to get velocity. Without IMU fusion, you're just going to get pose and orientation. So the IMU fusion is definitely tricky. It's doable. It's just more work on your part, whereas in Isaac ROS Visual Slam, it's kind of a batteries included, right? The other promising repo, which I didn't investigate, but I've heard good things about, is Chimera. So they have a native ROS2 layer wrapper around their code, so it's probably worth investigating. And so these stacks aren't GPU dependent, right? So with Isaac ROS Visual Slam and with the whole ecosystem of Isaac ROS, you're getting acceleration across the whole pipeline. And keep in mind, like when you're running things on the CPU and the GPU, accelerating doesn't mean you're running everything on the GPU. You're effectively transferring data between the CPU and the GPU. You're selectively accelerating the tasks that kind of bog down the CPU. So these stacks aren't GPU dependent, but if you probably could substitute the OpenCV calls with OpenCV CUDA or CV CUDA, and I have a little chart with the speed up on the right. And then the last alternative is probably something that I overlooked, and maybe I should have done this from the start, is just run PyQB Slam and then just create a ROS2 wrapper around that. I think that's probably one of the easiest things to try, especially since you're going to get native RGBD support. So that's it. I hope this talk was interesting. It wasn't too technical. Any questions?
Testing. There you go.
Thank you. I'm curious, have you ever tried that on like Isaac Sim platform, or why would you choose like a ROS2 or ROS platform?
I have not tried it on Isaac Sim. I think like you're talking about like Omniverse.
Exactly.
Yeah, I haven't tried it yet. I haven't really. For Omniverse, you need a pretty beefy desktop, and I don't have that right now. And what was your second question?
My second question would be, since you're using that for drones, right? Sorry if I missed the first part. Do you use like physics package from NVIDIA too?
No, we're not using any physics packages. So we're just doing localization. It's just basically we're feeding odometry data where the drone is in space to PX4, and then it gets fused into the Kalman filter.
So it's like coordinate information?
It's like what?
Coordinate information?
Yes, coordinates, correct. Yes, you do get pose data out of it, yes.
Cool. Then I guess I'll further discuss that maybe offline.
Yeah. Any other questions?
Anybody? Oh.
So I was just curious, do you get altitude data out of that too with the VSLAM portion rather than just like GPS,
You get local position Z, yes.
Okay, so local position
it is an FRD.
to actual ground rather
To
than
ground,
to
yeah, it's an
takeoff.
FRD,
Okay.
correct.
Yep.
It's just it's a reference, right?
Yep.
Obviously you can with PX4 you can fuse GPS with vision, and then you'll have if you have good GPS you'll get global position.
Yeah.
What sort of drift have you found that happens after time? Like, did you measure that already?
Drift, I haven't measured it, but I've noticed. So I've tried this on just generic stereo pairs, and if you don't have your IMU noise parameters like dialed in, it's gonna start like kind of toilet bowling. And then another thing is lighting, of course. It depends on your stereo pair, right? That's why they recommend the RealSense. I know they are expensive, but I think the active stereo pairs are very robust.
And are you trying this indoors or
Indoors,
outdoors?
correct.
Yeah, cool.
Yeah.
All right.
Is anybody still making RealSense? Because I heard that the license to it might have been transferred, or are you just buying old stock?
I think they spun out into RealSense from Intel, if I'm not mistaken. Someone feel free to correct me.
They're still selling the hardware, yeah.
Great.
So
Separate company now, so selling it as a new product.
Awesome. Any other questions? You work with him.
What's the next stage of this project in your mind that you're excited about?
I think Orb Slam 3. I think I've gotten pretty close, just using RGBD, but the IMU Fusion is the next big hurdle. Yeah, and then Orb Slam 3 is a little bit more compute intensive, so we'd have to accelerate a lot of the OpenCV calls, because it's a full SLAM stack. It's not just VIO, right? And we just care about VIO. That's the only thing we care about.
Yes or no answer. Am I going to have to update the white paper now?
Yeah.
Thanks.
I was wondering if you got to thinking about using it on an outdoor drone.
Yes. So I've experimented with different cameras. I think the RealSense D455 would be the best. But that stereo pair, as soon as you have like the distance to like whatever's in your environment starts to increase, the baseline works against you for detecting distance and stereo block matching.
And you need filters on the lens.
Yeah, I'm asking because this is what I do in my company.
Oh, nice.
If you feel free to contact me after.
Yeah, absolutely. What's your name?
Addy.
Okay, nice to meet you.
Anybody else? All right. So Ramon didn't come back, so I think we're going to start with the next session, which is the other Andrew. It's an Ascend block today. Yeah, great job.